there's some premises that I think make a lot of sense that we all, as healthcare providers and professionals, will understand that optimal neurology is a primary requirement for optimal health, right? Our body functions at optimal efficiency when the networks managing our body and mind are in balance. And the autonomic system is a part of that peripheral nervous system responsible for regulating all of those things that we don't think about, right? So we don't think about walking, we don't think about standing, we don't think about breathing, we don't think about consciously managing our pain. And all of these things happen through a very complex communication loop, neural networks that regulate the different various processes without actually thinking about them. Uh, Unfortunately, genetics, injury, illness, drug stress, and other trauma factors compromise this system. And misalignment within the communication of the neural networks can trigger dysregulation of physiological, emotional, and psychological function. So what does this mean? So in the big scheme of things, our neurology controls everything, right? So every physical, biological, chemical, emotional, psychological function in our body has a neurological regulation to it. There's a neurological control, a neurological, call it a program that regulates all those different things in our physiology. And if we look at the pyramid of our physiology, we have the biophysics, the ambulatory, our limbs, all those things that involve movement, standing posture. Above that is our biology. Above that is our biochemistry. And above all of it is our central nervous system, our neurology. And our CNS can impact all three of those things at the same time or independently. And there's usually a cascade of wellness. If the CNS and our mind is working, if healthy neurology, we're going to see a cascade of wellness. If there's something off in our CNS, something off in our neurology, we're going to see a cascade of problems, right? I think we've all seen that as healthcare providers, where one thing leads to another thing, there's nothing, and then all of a sudden somebody's in bed and they can't get out. But I think these are all table stakes of us understanding what makes our technology and what makes the science so profound, right? So how does our neurology impact our health? Optimal neurology equals optimal function. So when our neurology is optimized, when it's operating its best possible level, whatever that level is for each individual, we're gonna have a pain-free life. We're gonna have more energy. We're gonna have the best possible sleep. We're gonna have better mobility, more vitality, more strength. We're gonna have better posture and stability. Cognitive performance is gonna be optimal. We're gonna have a less stressful experience during the day. Our mood's gonna be better, and our metabolism, among other things, is gonna be optimized. When our neurology is not functioning optimally, we're gonna feel it, and we're gonna see it, right? We're gonna make some pain. We're gonna have low energy. We're gonna wake up tired because we didn't sleep well. Mobility is gonna be challenged. We might even have neuropathy issues. Recovery from illness, recovery from injury is gonna be compromised. We're gonna absorb that stress, that oxidant, that horrible thing that it does to our body. We're gonna see cognitive decline, whether it's memory, whether it's recall, whether it's executive function, decision making. Metabolism gets compromised. Mood and anxiety obviously become impairing factors in our quality of life. Right, so we want to get to the green. We want to get out of the orange to the red. We want to have a vital, healthy neurology, right? And so then the question is, so great. We want a healthy neurology. We want a healthy mind. We want great operation of our central nervous system. What causes neurological dysfunction, and how do you control that communication? So, what is obvious to us, and I think obvious to everybody in this call, is that the language of our mind is brainwaves: alpha, beta, delta, beta, gamma. That's how our mind communicates with itself internally, with the different networks that exist. And that's how it sends information from the central nervous system through its peripheral nervous system, through action potentials and neural signals. And that was the question that I was asking of leading scientists and neuroscientists of, okay, because of my mom's MS condition, to talk to me about these signals. You're saying that, well, because of demyelination, the neural signal isn't getting through. And my question is, well, what's the neural signal, right? You keep saying that, oh, the water's not getting to the pipes. Well, talk to me about the water. Talk to me about that information. And what became abundantly clear was that in 2009, 2010, 2008, our understanding, the world's understanding, science's understanding of the neural code was very rudimentary. We knew something was happening, and then we could see the brain waves, but it wasn't clear enough in terms of actually how that communication happened and what was the actual bits and bytes of that information. But we knew the data was there, so we had the data to start working on it. And what did we do from that point? So our approach to understanding. So we developed some proprietary algorithmic analysis tools. So basically, I'm a geek. I was in. I'm a software engineer by education, by training. I worked in encryption and security software for a long period of time. And over a period of time, I was able to write code. I was able to write programs, machine learning tools that allowed me to apply analysis to this metadata, to this massive sets of data that were sitting inside the Loretta database, because the software program that provided allowed for some rudimentary imaging, identification. What it didn't allow was for me to understand the regulatory processes, right? The process actually control those very critical health and wellness functions that we take for granted every day. So this approach and development process revealed some remarkable understandings and proprietary breakthroughs since then. So over time, we've had some incredible breakthroughs of our understanding of how that works. So the first breakthrough to a solution. So, when we take a look at our neurology, I think we'll all agree that it is the most complex thing that we know. Our neurology is actually more complex than the cosmos. So, the James Webb Telescope is out there and it's looking at the cosmos and the beginning of time and all these different things. I will argue that our neurology is infinitely more complex, and our mind is infinitely more complex than the cosmos out there. There's more going on in here than there's going on out there, right? So scientists and data scientists at MIT wanted to map the connectivity of our mind and the different networks. And they have supercomputers, and they started topographically, algebraically mapping the different connectivity between the different neural networks. And they reached 11 dimensions of connectivity. Now, everybody on this call, I believe, we probably operate on 3 dimensions. There might be one or two that might have reached a higher level of development, but for the rest of us mortals, we operate on 3 dimensions. So this is proprietary information. This took years and years to find and develop and to fine tune. We don't share this information because this really is the core understanding and intellectual property that we have. So, but that wasn't enough. So once we understand that we have this blueprint, this development sequence, we have to agree that there needs to be a regulatory process that controls that blueprint. It's like having a blueprint for a house. Great, we got a blueprint for a house. We also need a site supervisor to make sure that's being built the correct way. Our neurology and this is all thinking like an engineer, that we have this code is doing a bunch of calculations, but there needs to be a checksum to make sure those calculations are happening correctly. And that's what the next development was. The next breakthrough was a neuroregulatory process, that if there's these development sequences, there also need to be regulatory processes that govern the development of these sequences. And we were able to decipher and decode these processes in a set of complex neurosignals. Again, another few years of development and R&D over the last, not few years, 12 years, to develop these and to deduce these different regulatory processes for things like pain management, sleep management, mobility, vestibular response, stress management. All of these have neuroregulatory processes that we've deduced that are set of very complex sine waves that we've deduced that regulate these different processes. And this is because of the software that we've developed. This is because of the R&D that we've developed. And this is because of the measuring and the evaluation that we can do with generally accepted products out there. So when we measure this change and we measure these things, we're using, number one, the data that's already there. But when we measure it against new data, we have this comparative that shows us the changes that we're making. So we use FDA-registered EEG sets. We use FDA-registered software to prove our concepts. So how do we fix it? So remember we talked about at the beginning that these programs, these neural networks get stuck, compromised, damaged. And the reality is, how do we assist those? How do we correct them and get them back to factory reset? How do we get them back to operating at a normal function or an optimal function, right? And the best way to do that, to correct neural signals, would be generate a non-invasive process that could greatly compensate those dysregulated signals, right? So remember, these are just waves. And if you want to influence waves, we have to rely on interference, wave interference. It's just interference math. You have constructive interference and you have destructive interference. Constructive interference is when you can introduce a new signal to a previous signal, just waves, that'll help correct or amplify its function. A destructive signal is one that comes in and actually flatlines and it makes it zero. So we want to know, how do we affect and correct those complex signals and get them back to normal function? And the best way that we figured out was to generate compensatory signals to do that.